Looking at molar mass, we want to be able to determine quickly, easily, the molar mass of elements and compounds, and you're not going to have any problems with this at all. Now, I do have a periodic table with me. You'll want to have a periodic table with you as well, so that you can look and see where I'm getting these numbers. So if you're asked for the molar mass of arsenic, I chose it because it's kind of zesty, a little dangerous. Arsenic, you just look on the periodic table. It is atomic number 33, and you're finding, remember, that atomic weight, which is the same thing as the molar mass. So I find the number, and that is 74.92. Now, just a word about how I'm rounding. AP states to round all molar masses to the hundredths place. I would say majority of professors will have you do that as well. You might want to ask your professor just in case. Now that number, remember, is the grams of that element, arsenic, contained in 1 mole. Meaning I've got 6.022 times 10 to the 23 arsenic atoms. Let's do another one, magnesium. So you just look on the periodic table, is atomic number 12, and magnesium's molar mass is 24.31. I rounded to the hundredths place, grams in 1 mole. That's how many grams of magnesium we have in 1 mole. Now, let's start looking at some compounds. To find the molar mass of compounds, all you have to do is add the individual molar masses of each element. And this is how I set it up. I write each element to help me keep it straight, okay? And then I write the number of elements. Sodium, there's nothing, no subscript, so it's understood to be a 1. So I have 1 sodium. And then chlorine, same thing, no subscript, so it's understood to be a 1. So I multiply those by, we're going to have multiplication by 1. 1 atom of sodium, 1 atom of chlorine. Now I simply go to the periodic table and find their molar masses. The molar mass of sodium is 22.99, and the molar mass of chlorine is 35.45. Then we do the multiplication. 1 times 22.99 is 22.99. 1 times 35.45 is 35.45. So that's the mass contributed by the sodium, the mass contributed by the chlorine. Now we add this together, and we are going to get 58.44. 58.44. Now think about this. What's the unit? What's the unit? This is going to be the grams of sodium chloride for every 1 mole of sodium chloride. So it's grams per mole for a compound. All right, let's look at water now. You're going to have this one memorized. You use it so much. Sorry, there we go. Okay, how many hydrogens do I have? 2. Right, my hydrogen and oxygen. We've got 2 hydrogens. I have 1 oxygen. And then I come and I look at the periodic table. So the molar mass for hydrogen is 1.01, rounding to the hundredths place, and the molar mass for oxygen is 16. So I'm going to multiply that. We get 2.02. 1 times 16 is 16. So the hydrogen contributes 2.02, the oxygen contributes 16. Add this together, and we get 18.02. And remember the unit, grams of water for every 1 mole of water. There we have it. Nice. Let's do another one. I wanted to do this one, aluminum oxide, because we had subscripts on every element. Okay, aluminum. So my aluminum, we've got 2 of those. Oxygen, we have 3 oxygen atoms. I come to look at the periodic table. Aluminum, atomic number 13, is 26.98. So we've got 26.98. Oxygen, now oxygen is 15.999. That's why it's rounded to 16. 16. Okay, I go ahead and multiply these. Let's see here. We're going to get 53.96 and 64. Now all we have to do is add this together. So we will have 100, let's see here. So 96. Did I do that right? I don't think I did for some reason. 96. Yeah, that looks right. So 100 and, oh, do you know what? I see my mistake. I'm so sorry, you guys. 3 times 16, in case you're wondering, is 48, not 64. There we go. All right, now we can add this together. So we are going to have 101.96, and our unit, grams per mole. So if I have 101.96 grams of aluminum oxide, that is going to be 1 mole. 6.022 times 10 to the 23 formula units of aluminum oxide. Now this is kind of a tricky one that I want to do with you, a hydrate. Finding the molar mass of a hydrate. Let's take copper sulfate pentahydrate. Students wonder how you deal with this, what that little dot means. So the dot is just indicating that this is a hydrate compound. You will have 5 water molecules for every 1 copper sulfate. This is how I recommend that you find the molar mass. Let's find the molar mass of the copper sulfate and the total molar mass of 5 water molecules. So we've got copper, 1 of those. The molar mass of copper is 63.55. And then sulfur, the molar mass is 32.06. Be looking at your periodic table to check this. And oxygen, we've got 4 of those, 4 of those, and we have 16. Okay, do our math, multiply 63.55, 32.06, and here is our 64. I actually did a cheat, put this on the calculator. It's going to be 159.61. Now if I stopped right there, that is just the molar mass of the copper sulfate in grams per mole. But we have 5 water molecules that are attached to this. So let's do the water molecules. I would just find the molar mass of water. And we did that. We determined that the molar mass of water is 18.02. Remember, you've got 2 hydrogens, 1 oxygen, that's 16, multiply 2.02, 1 times 16, 16. There we have it, 18.02. Now remember, that's for 1 water molecule, but I have 5. So we will do 5 times 18.02, and that will give us 90.01. Excuse me, 90.1. Okay, so the molar mass of 5 water molecules is 90.1. Now all we have to do is add these 2 together. Add those 2 together, and we'll get the total molar mass for this hydrate. Okay, so we add the 90.1, and our final answer is 249.71, and you're thinking, what's the unit on this? Grams per mole. So 249.71 grams of copper sulfate pentahydrate when you have 1 mole. And I want to show you again what this is. There it is. That's what it looks like. That's 1 mole of copper sulfate pentahydrate. If I put this on a scale, just the compound, it would weigh 249.71 grams. So there you have it, calculations for molar mass, elements, and compounds. Thank you.